Hello, my name is You Jun. Today I'm going to go through the tutorial number 3. The first question of the tutorial is using the Gaussian elimination by back substitution to solve the following problems below. So first of all, I convert the equation to become the augmented matrix here. Then I use the Gaussian elimination to solve the matrix. First, R2 plus 4R1, R3 minus 7R1, R3 plus 2R2. As you can see, there is all 0 in the last row in the matrix. So it means you have infinite of solution or infinite of answer in this equation. So I convert this matrix to become the equation back. So x minus 2y plus 3z equals to negative 83. Negative 3y plus 6z equals to negative 129. Y equals to 43 minus 2z. So I substitute equation 3 into equation 1 and get the final answer of x equals to 3 plus z. Since it have infinite of answer, so the final answer will be an equation. So x equals to 3 plus z, y equals to 43 minus 2z, and z will equals to z. So now I'll go through the equation 1, the question 1b. So like the same, I convert the equation to augmented matrix. Then I use Gaussian elimination to solve the matrix. First R2 plus 2R3, then 3R3 minus R1, then R3 multiplied with 9 over 14, R3 minus 2 as the last. So like the same, I convert the matrix back to the equation again. Negative 9x minus xy minus 7z equals to negative 119. 9y plus 2z equals to negative 50. 4 over 7z equals to 8 over 7z. So the z will be 2. So I substitute z into the equation number 2 and get the final of y equals to negative 6. Then I substitute z and y back into the equation number 1 and get the final answer of x equals to 17. So x equals to 17, y equals to negative 6, and z will equals to number 2. So now I will continue the tutorial 3 to question number 2. So the question number 2 is to find the matrix of the inverse matrix. What I mean is inverse matrix by using the elementary row operation. For 2A, the 2A is given a matrix A, so I need to find the inverse matrix of matrix A. First of all, I write the augmented matrix with the identity matrix F the beside there. So this is the matrix that I write. Then I use the elementary row operation to solve the matrix to find the inverse matrix. First, I multiply R1 with 1 over 2. Then R1 plus R2 equals to the new R2. Negative 2R2 equals to the new R2. Negative 3R1 plus R3 equals to new R3. Negative 5 over 2 R2 plus R1 equals to new R1. 23 over 2 R2 plus R3 equals to R3. I multiply R3 with negative 1 over 76. 7 R3 plus R2 equals to R2, and negative 17 R3 plus R1 equals to new R1. So as you can see, the final answer will change from the identity matrix here to become the final answer of inverse matrix. What I mean is the final answer will get in the place of the identity matrix, and the identity matrix will go front to the in the matrix. So this is the final answer for inverse matrix. 7 over 76, negative 11 over 76, negative 17 over 76, 15 over 76, 9 over 76, 7 over 76, 13 over 76, 23 over 76, and 1 over 76. So now I will go through the tutorial 3 to the last question, which is question 2b. The question 2b give matrix B, so I need to find the inverse matrix of matrix B. Like the same, I rewrite the matrix to with the identity matrix. Then I use elementary row operation to find the inverse matrix of B. So first 3R1 plus R2 equals to R2, negative 5R1 plus R3 equals to R3. I multiply R2 with 1 over 13, then 60R2 plus R3 equals to new R3. Multiply negative 1373 to the R3 to become the new R3. Negative 2 R2 plus R1 equals new R1. Negative 44 over 13 R3 plus R1 equals new R1. Last, negative 4 over 13 R3 plus R2 equals new R2. So to find the inverse matrix, I need to change the value in front to become the identity matrix. So the last, as you can see, in the last matrix here, the value initially here become the identity matrix, and the identity matrix will become the inverse matrix value, which is this. So the inverse matrix B is equals to this value, negative 15 over 79, 42 over 79, 44 over 79, 13 over 79, 11 over 79, 4 over 79, 17 over 79, negative 16 over 79, negative 13 over 79. So this is the final answer of the inverse B. So that's all from tutorial 3. Thank you very much. Bye bye.